Hey guys, welcome back to covalent bonding. In the previous lecture, we have practiced few of the covalently bonded structures. One of them was, let me go back. And first of them was the molecule of the elements. One of them was hydrogen. The second example was for chlorine. The third example was for iodine. Fourth is methane. Fifth is ammonia. Sixth is carbon dioxide, and the seventh is water. Eighth is ethane. And now we are going to make the practice uh for next of the covalently bonded structures. Let's make the next one, and that is called this is the ninth one, and that is called ethane. Ethane. Now, might be this a question in your mind that is there any relationship between ethane and ethene? Yes, we are going to open this mystery, unlock this mystery when I will teach you the topic of organic chemistry, inshallah. But right now, just focus on the thing that there is something called ethane and it has formula C2H6. As it is a combination of non-metals, so it will be formed by covalent bonding. There is another compound called ethene. Their formulas are different. Formula of ethane was C2H6. Now the formula of ethene is C2H4, and both of them are made up of carbon and hydrogen. So both of them show covalent bonding. Okay. So here carbon is 6 and 12, and that is called 6 converting itself into 2 and 4 electronic configuration. When we are talking about hydrogen, each of hydrogen will have one electron in its outermost shell. Each of hydrogen atom always wants to have two electrons in its outermost shell, whereas carbon atom has four electrons in its outermost shell. Its destination is to approach eight electrons in its outermost shell. Okay, now we can see this thing that carbon electrons are represented with cross, whereas hydrogen electrons are represented with dot. And now we are going to draw the structure. This is carbon, and these are the two electrons of carbons, both of the carbons. So this is this, and these are the electrons of this carbon. Now I'm going to draw the electrons of hydrogen, and these dots are the electrons of hydrogen. Now we can go back, and I am drawing these as a sharing region, and these are the sharing regions of one carbon and three hydrogens, whereas these are the sharing regions of this carbon and the three other hydrogen atoms. Okay, let's draw, write down the hydrogen atoms here. So these purple ones are the hydrogen atoms. Okay, now I'm going to draw the sharing region diagram. You can see this thing. This is the first carbon atom. This is the second carbon atom. And now we are going to draw the three hydrogen atoms carbon with each of the carbon atoms separately. You can see these are the three with one and the three with the other carbon atom as well. So this is carbon, this is carbon, this is cross and cross between the two. And here, as it is an ethene, so you can see it is it should have four electrons rather. I have drawn 6 electrons here, so I have to erase this and I have to erase this as well. Whereas both of the carbon atoms are sharing two more electrons with each other. Okay, so the two carbon atoms are sharing 4 electrons with each other. 2 electrons are of one carbon atom, whereas 2 electrons are of other carbon atom. So here I am going to rub this as well, and I'm going to rub this as well, and I'm going to complete these electronic shells. Okay, these are of carbons. All right, now you can see this is hydrogen, this is hydrogen, there is a dot and a cross, there is a dot and a cross, there is a dot and a cross, there is a dot and a cross over there. Okay, so we can say finally it is like this. It is the two hydrogens with each of the carbon atom. In case of ethane, three of the hydrogens with each of the carbon atom, whereas in case of ethene, two of the hydrogens with each of the carbon atom. As carbon atom has to share 4 electrons, so they are sharing two electrons with each other, and the remaining 2 electrons with two of the hydrogen atoms separately. Okay, So this is the structure of ethene, and now I'm taking you to another one, and that is called ethine. All right, so the name is ethine. This structure is rarely asked in the past papers, if you will check the past papers, but it is just giving you an idea that how to develop the structure from the given formula, for example. All right. So now I'm telling you what is the formula of ethine. It is C2H2. Okay, yes. Ethane, ethene, and ethine are interconnected with each other, and how they are interconnected with each other, this we will discuss, inshallah. But right now, I am just telling you that ethane has a structure of C2H6. Ethene has a formula of C2H4, whereas ethine has a formula of C2H2. Okay, now we can say this is carbon, and now I am representing the carbon electrons with a cross and hydrogen electron with a dot. All right, 1, 2, 3, and these are the electrons of the other carbon atom, and this is this and this, and this is like this. Now I'm going to draw the electrons of hydrogens with the dot. Okay, and with the dot, and I'm writing hydrogen atoms here. This is this. There is one sharing region between one carbon and one hydrogen. There is one sharing region between the second carbon atom and its hydrogen. And there is only one sharing region between the two carbon atoms, in which there are 6 electrons, or you may say 3 pairs of electrons. One pair of electrons, single covalent bond. Two pair of electrons, double covalent bond. 3 pairs of electrons, triple covalent bond. So here you can write like this as well, that as carbon has 6 electrons, so its electronic configuration will be 2, 4, whereas each of hydrogen has 1 electron in its electronic shell, so it is called one only. So carbon atoms want to approach their electronic destination from 4 to 8. That's why they are going to share all 4 electrons. Whereas when we are talking about hydrogen atoms, they are going to share their 1 electron to approach the electronic destination of 1. Now, this is the next one, and there is a sharing region diagram which we have developed already. And now this is called the overlapping diagram. So here we are going to write carbon, carbon, and both of the carbons are sharing 3 electrons with each other. Now this is the electronic shell for hydrogen, and there is one more hydrogen with the other carbon atom as well, and we are going to write hydrogen atoms here, and this is the dot and cross for hydrogen and carbon atoms. Dots are for hydrogen atoms. This is the key at the top, and remember this thing, that it is important. Sometimes the examiner himself is saying that carbon should be represented with the cross and hydrogen should be represented with the dot. Over there you cannot change the examiner's suggestion. Okay, and you have to follow his instructions. But right now I'm just telling you that here you have to select the key if examiner is not giving you any key. So this is about ethine, and right now the final structure is like this, and this is both of the hydrogens on both sides, whereas the carbon atoms in the center. All right, so this is how we are going to draw this carbon and hydrogen combination for ethine. Now we are going to draw one more, and that is number 11, and that is called, for example, okay, instead of this, okay, CCl2F2, okay. So it is difluorocarbon, okay. First point is this, that as it is a combination of carbon and chlorine, I mean to say it is a combination of non-metals, so it is going to follow covalent bonding. Okay, this is the point number 1. Okay, now I know this thing already, that it has 12 mass number, whereas 6 is the atomic number. So 6 and 2 and 4 electrons in the outermost shell of carbon. Whereas when we are talking about chlorine, it has 17 atomic number. So it will be 2, 8, 7. It means there are 7 electrons in the outermost shell of chlorine. It wants to share 1 electron. Carbon has 4 electrons in its outermost shell, so it is going to share 4 electrons. When we are writing about fluorine, it is 7, 9, and 19. So it has also 9 and 2 and 7. 7 is the electrons in the outermost shell of chlorine, and 7 are the electrons in the outermost shell of fluorine. Both of them are going to share one electron. Okay, let's see. Okay, this is carbon, and these are the four crosses of carbon. These are the four electrons in the outermost shell of carbon. Now we are going to draw the electrons of fluorine. These red dots are the electrons of fluorine, and now we are going to draw the blue dots. These blue dots are the electrons of fluorine. All right, now let's see. Now we are going to complete it. Okay, before moving there, I would like to write, this is not good. Okay, this is good for writing this. Okay, and this is chlorine and this is fluorine. Whereas now, okay, so these are the electrons of chlorine and fluorine. Right now, I'm going to draw the electrons. So this is number one. This is number one, chlorine, and it has all of its 6 electrons. This chlorine has also its 6 electrons as valence shell electrons. Okay, remember, guys, I have told you that valence shell electrons are those electrons which are part of outermost shell. Now I am telling you about lone electrons and bonded pair electrons again. Look at here. These are the electrons of chlorine which are in the valence shell. So how many electrons are there in the outermost shell of chlorine? 7. Out of 7 electrons, it has sent 1 electron in the sharing region. So this is the bonded electron. What about these 6 electrons? These 6 electrons are part of the valence shell, part of the outermost shell, but they are not part of the sharing region. So these electrons are called lone electrons, Lone. All right, these electrons are called lone electrons. Now I'm going to draw the electrons for fluorine. You can see these are the electrons. These 6 are the electrons of fluorine, which I am drawing with the blue color. All right, now we can complete the sharing region, and this is the sharing region right now. Instead of, yeah, I can select the green color. Okay, so this is the sharing region number 1, number 2, number 3, and this is the final sharing region between carbon and fluorine. All right, now look at here. This is the carbon, central carbon. This is one of the atom. This is the second atom, whereas this is the third one, and this is the fourth one. All right, now I am writing here carbon. This is fluorine. This is chlorine, and this is chlorine, and this is fluorine. This is dot and cross, dot cross, dot cross, and the final dot cross. Okay, whereas right now we are going to complete the electrons of chlorine and fluorines here in the outermost shell. You can see I am drawing these electrons of fluorines and chlorines. All right, now we can say what will be the final diagram. It is chlorine on one side of carbon, chlorine on the other side of carbon. Okay, I should draw it on the same way as we are drawing it in the next one. Okay, if you will change the pattern, it can create a confusion. Otherwise, there is no problem. So you can write this and this. Okay, so this is how we are going to draw the structure of difluorocarbon. Okay, one more thing which I would like to inform you about difluorocarbon, that it is a CFC. You have heard the name of CFC already. These are chlorofluorocarbons. Okay, so this is one of the example of CFCs. And what are CFCs? CFCs are those chemicals, these CFCs are those combination of carbon, fluorine and chlorine which are coming to earth atmosphere when there is an ozone depletion. All right, and why there is an ozone depletion? This ozone depletion is due to chlorofluorocarbons. And when ozone is getting depleted, ozone is one of the layer in the earth atmosphere. So when chlorofluorocarbons are depleting this ozone layer, then as a result, what is happening? Ultraviolet radiations of sun can approach the earth environment and they can cause skin cancer. So what is the story? I'm summing up this whole. chlorofluorocarbons are the specific type of chemicals which are producing during different industrial processes and during different aerosol from the different aerosol propellants, as well as the cooling appliances. The compressors of the cooling appliances are releasing chlorofluorocarbons. Nowadays, industries and the scientists are controlling this production of chlorofluorocarbons in our environment. But what's happening, that these chlorofluorocarbons, when they are once produced, they are quite very stabilized type of compounds. They go in the upper environment of atmosphere, and there is a third layer of our atmosphere which is called as stratosphere. This is called as stratosphere. Stratosphere is made up of ozone. Ozone has a formula of O3, and when these chlorofluorocarbons are approaching this ozone, they are reacting with this O3 and they are transforming, they are shifting this O3 into O2, into oxygen, O2, all right? And as a result of that, there is a hole, there is a depletion in the ozone layer. You people have heard this thing, must have heard this thing about the hole in the ozone layer, and due to that hole, what's happening, ultraviolet radiations of sun can approach the earth environment, and finally those ultraviolet radiations are causing skin cancer, all right? So this is all happening. So this is a very concerning type of compound which we have drawn. Okay, so this was all about today's lecture. Inshallah, I'll be back to you with few more examples, and then we will move towards the properties of the covalently bonded structures, and finally I will teach you about the giant covalently bonded structures. Inshallah, may we all have a good day. Thank you very much.